morning, our esteemed viewers. If you remember in our previous series, we started with the way to write the correct formula of different compounds. And I believe that you must have understood all those ones very well. So today we are looking at the applications of the formula, the application of correct formula through the calculation of relative molecular mass with short form RMN. So we are going to look at a few examples written on the board. For the first one, sulfur 4 oxide. Second one, nitrogen 5 oxide. Third one, sodium chloride. Fourth one, lead 2 chloride. The fifth one, iron 3 oxide. So let's start with the first one without wasting any time. If you remember sulfur 4 oxide, when we are treating the application of, we are still writing the correct formula of different compounds. We say sulfur 4 oxide is formed between sulfur and oxygen. Sulfur, oxide, oxygen. So sulfur has valency of 4 as written in the brackets. Oxygen from oxide has valency of 2 from the periodic table of the first 20 elements. 4 for sulfur will go to oxygen, 2 for oxygen will go to sulfur. So that now gives us S2O4. 2 goes to sulfur, 4 goes to oxygen. So then by the time we simplify the number of atoms to the simplest term, to their simplest term, then that will now give us SO2. 2 cancel 2. 1. 2 in 4, 2. Sulfur 4 oxide SO2. So having known that, now come to the calculation of relative molecular mass of sulfur 4 oxide. RMN of sulfur 4 oxide is the relative atomic mass of sulfur plus relative atomic mass of oxygen, SO2. Then that will lead us to relative atomic mass of sulfur plus 2 times relative atomic mass of oxygen, because we are multiplying what we have in the oxygen by its number of atoms, which is 2. Then we go ahead to apply the formula. Relative atomic mass of sulfur as given in our value is 32 plus 2 times relative atomic mass of oxygen is 16. Then that leads us to 32 plus 2 times 16, which is also 32 mathematically now. Then that will give us what, 64. So relative atomic mass of sulfur 4 oxide is 64. So what I just wanted to know here is that the inability, if you fail to get the correct formula and you apply wrong formula to carry out the calculation, you may end up getting the wrong answers. So the knowledge of correct formula is very, very important. Let's go to the second one. RMN of nitrogen 5 oxide is what you have. Okay, nitrogen 5 oxide in the first place is N2O5. You apply the principle that we explained in the first one and the previous series. N2O5. N2O5. So it's what we have as N2 plus what we have as O5. That is the calculation of the relative molecular mass of nitrogen 5 oxide. Then that now leads us to 2 times the relative atomic mass of nitrogen plus 5 times relative atomic mass of oxygen. So 2 times relative atomic mass of nitrogen is 14 as given, plus 5 times relative atomic mass of oxygen is 16 as given. So mathematically that gives us 28 plus 80. 28 plus 80. 28 plus 80 will give us 108. So relative molecular mass of nitrogen 5 oxide is 108. For sodium chloride, that one is a common name. It is sodium chloride is common. It's what we call common salt. It is salt we use in cooking at home. So the formula for sodium chloride is NaCl. NaCl. If you follow the principle of writing the correct formula, you are going to get NaCl. So that means that the RMN of NaCl is equal to what you have as a relative atomic mass of sodium, which is Na, plus relative atomic mass of chlorine, which is Cl. So that will now lead us to relative atomic mass of sodium is 23 as given, and chlorine is 35.5 as given. So when you add the two together, you are going to get 58.5. 58.5. That's the relative atomic mass of sodium chloride, 58.5. Then the fourth one, the first thing, as usual, also the first thing you are to do here is to try and write the correct formula of lead 2 chloride. The correct formula for lead chloride is PbCl2. Yes, because it says lead 2 chloride, lead will be having the valency of 2 and chlorine valency of 1. When they exchange their valency, the 2 for lead will go to chlorine, 1 for chlorine will come to lead. So that is why it is PbCl2. Then the RMN, relative molecular mass, will now be relative atomic mass of lead plus relative atomic mass of chlorine. That now leads us to what you have as lead, relative atomic mass of lead plus 2 times what you have as relative atomic mass of chlorine. So then from there we begin to apply the given value. Lead is 207 as given, plus 2 times chlorine, which is what? 35.5. So that will give us 207 plus 71. So that will give us that will lead to 278. That will become 278. So that is the calculation of RMN of lead 2 chloride. Then iron 3 oxide is Fe2O3. And I believe that you know how we come about that. Iron has valency of 3 as given in the bracket. Oxygen from oxide, the valency from the periodic table is 2. So when they exchange their valency, 2 for oxygen will come to iron and 3 for iron will go to oxygen. That's why we have Fe2O3. Then the RMN is calculated as follows. RMN of iron 3 chloride is what you have in as Fe2 plus O3, which is equal to 2 times relative atomic mass of iron plus 3 times relative atomic mass of oxygen. So that will now give us 2 times what you have as iron is 56 plus 3 times what you have as oxygen. So that now leads us to 2 times 56 will give us 2 times 6. This is 12. 2 times 5, 10, 11, 112. 112 plus 3 times 16. That is 3 times 6, 8. 3 times 1, 3 plus, which is 4. 48. 112 plus 48 will give us 160. 160. So that is the relative molecular mass of iron 2 oxide. And I believe that you are all getting all this calculation rightly. And by the time we come again to continue the series, we will explain what it's all about more. Thank you.